Students, welcome to the today's lecture. In our last class, we discussed about dynamic lift. So the motion through fluid, that is called what? Dynamic lift. So in this dynamic lift, what happens? See, there are two illustrations. Right? So what are those illustrations? Suppose, see, if the ball is right, throw like this. See, if the ball is thrown like this means without spin, right? So without spin, the ball is what we throw. What happens here? There is no pressure difference between up and low. There is no pressure difference between up and low, right? So this is normal without spin or no spin. There is no pressure differences. The ball will go like straight. Right? So then how the ball spins? Then what happens? How it takes the time? Right? See, here, if the ball spins, same kind, right? If the ball spin means, see, the ball will goes like this. Right? If the ball will goes like, if the ball is no spin means this velocity is continue here to same velocity, but this velocity came here. It completely, what happens? Change. See here, once again, in this case, when the ball spins, see, the pressure P is high, velocity low. So here velocity V is high, pressure low. See, ಯಾವಾಗ ನಾವು ಏನು ಈ ರೀತಿ ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಥ್ರೋ ಮಾಡಿ ಬರ್ತಿರ್ಬೋದು. ಈ ರೀತಿ ನಾವು ಥ್ರೋ ಮಾಡಬೇಕಾದ್ರೆ ಸೊ ಏರ್ ಈಸ್ ದಿಸ್ ಸೈಡ್. ಈ ಸಪೋಸ್ ನಾವು ಗಾಡಿನ ಹೊಂದಿರ್ತೀವಿ, ಈ ರೀತಿ ನಾವು ಗಾಡಿನ ಹೊಂಟಾಗ ಏರ್ ಮನುಷ್ಯನ ಏರ್ ಯಾವಾಗ ಮುಖಕ್ಕೆ ಬರ್ತದೆ ರೈಟ್, ಬ್ಯಾಕ್ವರ್ಡ್. ಸೊ ದೆನ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ಅ ಪ್ರೆಷರ್ ಡಿಫರೆನ್ಸ್ ದೇರ್. ಸೊ ನಮಗೆ ಇಲ್ಲಿ ಏನು ಸಿಗ್ತೈತಿ? ಪ್ರೆಷರ್ ಡಿಫರೆನ್ಸ್ ಸಿಗ್ತೈತಿ. Right? So all net force is 0, but in right? Velocity is high, pressure is low. So this is our dynamic lift. So when the ball spins, if otherwise the ball spins, if there is no spin, there is no pressure difference. If there is a spin, what happens there? There is a pressure difference. Right? So see, upside pressure is low. When the pressure is low, the ball is going high with the velocity. When the ball's velocity is come down, what less, automatically pressure high, the ball coming like this, right? this upward lift or dynamic lift is this process is called as Magnus effect. Magnus effect. ಇದಕ್ಕಿಂತ effect ಅಂತ ಕರೀತೀವಿ ನಾವು. Magnus effect ಅಂತ ಕರೀತೀವಿ. Magnus effect ಗೊತ್ತಿದೆ. Magnus effect. Magnus effect. ಇದಕ್ಕಿಂತ ಕರೀತೀವಿ Magnus effect ಅಂತ ಕರೀತೀವಿ. Right. After this one, discuss Torricelli's law. Torricelli's law for flow. Or it is also known as speed of the flux, right? So here what happens, a flux means outflow of fluid. So fluid ಹೊರಗೆ ಹೋಗೋದ್ರಿ, outflow ಹೊರಗೆ ಹಾಕೋದ್ರಿ. ಕ್ಲಿಯರ್ ರೀ? ಅದಕ್ಕೆ ಒಂದು ಟೊರಿಸಿಲಿ ಅನ್ನುವಂತ ಸೈಂಟಿಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾನೆ, ಅದರ ಫ್ಲೋ ಬಗ್ಗೆ ಏನ್ ಮಾಡ್ತಾನೆ, ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾನೆ. ಫ್ಲೋ ಬಗ್ಗೆ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಮಾಡ್ತಾನೆ. ಫ್ಲಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಫ್ಲಕ್ಸ್, ರೈಟ್? ಸೊ ಹಿಯರ್ that Torricelli, what he did found that outflow of fluid can be done. How ಹೊರಗೆ ಹೋಗಬೇಕಾದ್ರೆ it taking how much speed it will take, he find out, right? Here what, there is a cylinder, right? There is a cylinder. In this cylinder, see here, I am going to take this one is a space, this one is a space, this is open space, right? So here I am going to take this is A2, this is A1, right? So here the height is h, the total height is h, right? From here to here, I will see, from here to here, or from here, right? So this is h1, this is h2, right? So see, this is complete height from our cylinder surface h, right? So this is point O, right? You pointing A, this is a outflow. ಇದಕ್ಕೆ ಏನಂತ ಕರೀತೀವಿ? outflow ಅಂತ ಕರೀತೀವಿ, orify ಅಂತ ಕರೀತೀವಿ. ಇದಕ್ಕೆ ನಾವೇನಂತ ಕರೀತೀವಿ ಅಂತಂದ್ರೆ, it is also called as orifice. So orifice, it is a small hole. ಅದಕ್ಕೆ ನಾವೇನಂತ ಕರೀತೀವಿ? orifice ಅಂತ ಕರೀತೀವಿ. ಗೊತ್ತಿರಲಿ. See here what happens. In this area, the velocity is very less. So in this area, if the going outside means the velocity is there. See, from the surface of up to this much, the height is h. From orifice to this surface, the height is h1. From here to orifice is h2. Right? So here the liquid, which type of liquid we took here? Ideal liquid. Ideal liquid. Right? Ideal liquid. So here what happens? When we are open this surface, when we are open here, and another one thing, here also atmospheric pressure is there, here also, this is also outside, here also atmospheric pressure, here also atmospheric pressure, right? Here also atmospheric pressure, right? See, here what happens? If this area is greater than A1, A2 is much greater than A1. A2 ಏನಿದೆ A1 ಗಿನ ದೊಡ್ಡ ಏರಿಯಾ ಐತೆ, A1 ಗಿನ ಏನಿದೆ ದೊಡ್ಡ ಏರಿಯಾ ಐತೆ. ಸೊ ಯಾವಾಗ ನಾವು ಇದನ್ನ ಓಪನ್ ಮಾಡಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೀವಿ ಅವಾಗ ಏನಾಗ್ತೈತೆ, ಔಟ್ಫ್ಲೋ ಆಗ್ತೈತೆ, ಔಟ್ಫ್ಲೋ ಆಗ್ತೈತೆ, ಗೊತ್ತಿರುತ್ತೆ, ರೈಟ್? ಹಿಯರ್ ಸಿ, ನಾ ಏನು ಹೇಳ್ತೇನೆ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಅವರ್ ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್. ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಅವರ್ ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್. ನಾವು ಏನು ಮಾಡ್ತೇವೆ ಇಲ್ಲಿ ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಏನ್ ಮಾಡ್ತಿದ್ವಿ? ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್, ರೈಟ್? ಸೊ ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್ ಅಂತಂದ್ರೆ ಏನೈತೆ ನೋಡ್ರಿ, ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್, ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್. ಸೊ ಹಿಯರ್ ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್ ಈಸ್, ನೋಡಿ, ಬರ್ನೌಲಿಸ್ ಥಿಯರಮ್ or according to Bernoulli's theorem, according to Bernoulli's theorem, right? According to Bernoulli's theorem, according to Bernoulli's theorem, according to Bernoulli's theorem, according to Bernoulli's theorem, right? Right. Total energy at this point, E point, right? E point is better, A point is better, E point is better, B point at A point, at A point is equal to total energy at B point. Total energy at B point. Right. See. So liquid ಯಾವಾಗಲೂ ಏನಿದೆ, ಡೆನ್ಸಿಟಿ ಇದೆ, ಗೊತ್ತಿದೆ. ಲಿಕ್ವಿಡ್ ಯಾವಾಗಲೂ ಏನಿದೆ, ಡೆನ್ಸಿಟಿ ಇದೆ. ಸೊ ಪ್ರೆಷರ್, ರೈಟ್? ಪ್ರೆಷರ್ ಎಂತ ಪ್ರೆಷರ್ ಇದೆ? ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಇದೆ. ಎಂತ ಪ್ರೆಷರ್? ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಪ್ರೆಷರ್ ಪ್ಲಸ್ ಪ್ಲಸ್. ಈಗ ನೋಡ್ರಿ, ಇದು ರೀ V2 ರೀ, ಇದು V1 ರೀ. ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಇದು ಹಿಂಗ್ ಹೋಗ್ಬೇಕ್ರಿ, ಬರ್ತದ್ರಿ, ಆಟೋಮೆಟಿಕಲಿ ಫ್ಲೋ ಆಗ್ತೈತೆ. ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಬರ್ಬೇಕಾದ್ರೆ V2 ವೆಲಾಸಿಟಿ ಇಲ್ಲಿ ಬರ್ಬಹುದು, ಸಾರಿ ಇದನ್ನ A2 ಅಂದಿದ್ರೆ V1 ಬೇಕಾದ್ರೆ ಇದನ್ನ ಏನ್ ತಗೋರಿ, A1 A2, ಇದು V1 V2, ಇದು V1 ವೆಲಾಸಿಟಿ, ಇದು V2 ವೆಲಾಸಿಟಿ, ರೈಟ್ ರೀ? ಒನ್ ಸೆಕೆಂಡ್, ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಏನಾಗ್ತದೆ? ರೋ ಜಿ ಎಚ್, ರೋ ಜಿ ಎಚ್, ಕ್ಲಿಯರ್? ಒನ್ ಸೆಕೆಂಡ್, ಪ್ಲಸ್ ಈಗ ನೋಡಿ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಬಂದು ಬರ್ಬೇಕಾದ್ರೆ ಎಂತ ಎನರ್ಜಿ ಇರ್ತದೆ? ಪೊಟೆನ್ಷಿಯಲ್ ಎನರ್ಜಿ ಇರ್ತದೆ. ಬಟ್ ಇದು ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇರ್ತದೆ, ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇರಂಗಿಲ್ಲ. ಸೊ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇರಂಗಿಲ್ಲ, that will be zero, that will be zero. ನಾನು ಕೆಳಗೆ, ರೈಟ್? ಸೊ then once again, pressure, atmospheric pressure, right? Atmospheric pressure, atmospheric pressure. So atmospheric pressure, once again, very important thing here. What is that important thing here means horizontal equilibrium. So horizontal equilibrium, is there potential? No. So then I'm going to write 0, 1 by 2 rho V1 square. So kinetic energy is there. Illinda ಇಲ್ಲಿ motion ಆಗ್ತಿದೆ, kinetic energy is there. Very important thing. So pay pressure, atmospheric cancel, right? ಅದು 0 ಬಿಡಿ. ಏನು ಉಳಿತು? Rho, sorry, 1 by 2 rho V1 square is equal to rho GH, rho GH, right? So ಈ rho ಏನಾಯ್ತು? ಕ್ಯಾನ್ಸಲ್ ಆಯ್ತು. V1 is equal to ಎಷ್ಟು gh. So then ನನಗೆ ಏನು ಬೇಕ್ರಿ ವೆಲಾಸಿಟಿ ಬೇಕ್ರಿ v1 square is equal to 2gh 2gh, right? So then once again v1 is equal to root 2gh 2gh. Very important thing, very important thing, very important thing from orifice 2gh 2gh. Right, so this is what speed of efflux, speed of efflux. So e v1 ಏನಂತ ಹೇಳ್ತೀವಿ ನಾವು ಸ್ಪೀಡ್ ಆಫ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ, ಸ್ಪೀಡ್ ಆಫ್ ಫ್ಲಕ್ಸ್. ಇದಕ್ಕೆ ನಾವು ಟೋರಿಸಿಲೀಸ್ ಲಾ ಅಂತ, ಟೋರಿಸಿಲೀಸ್ ಫ್ಲೋ ಅಂತ ಕರಿತೀವಿ, ಟೋರಿಸಿಲೀಸ್ ಲಾ ಅಂತ ಕರಿತೀವಿ, ಸ್ಪೀಡ್ ಆಫ್ ಫ್ಲಕ್ಸ್ ಅಂತ ಕರಿತೀವಿ, ರೈಟ್? ಸೊ ವೆಲಾಟಿಕ್ ಯಾವಾಗಲೂ ಈ ಒಂದು ಲಿಕ್ವಿಡ್ ಫ್ರೀಲಿ ಫಾಲ್ ಆಗಬೇಕಾದ್ರೆ ಏನು ವೆಲಾಸಿಟಿ ಇರುತ್ತೆ, ವೆಲಾಸಿಟಿ ಅದನ್ನು ನಾವು ರೈಟ್. ಸೊ after this one next topic is viscosity. 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 So here it is property of liquid, property of liquid. It tends to resist. It tends liquid by virtue of which it tends resist relative motion in different layers, in motion, relative motion between different layers, between different layers is called what? Viscosity. Viscosity. See here what happens. It is a property of a liquid. It is a property of a liquid by virtue of which it tends to resist the relative motion. If suppose here the water is flowing like this, right? Idella ಏನು ಮಾಡಾಕತ್ತಿ ವಾಟರ್ ಹರಿಯಾಕತ್ತಿ, right? So ಈ ವಾಟರ್ ಹರಿಯಾಕತ್ತಿ ಅಂತಂದ್ರೆ, so this on this surface to this surface the water is flowing. This surface to this surface is water is flowing. ಈಗ ನೋಡಿ ಇದಕ್ಕೆ ಹತ್ತಿರ್ತದೆ ಅಂದ್ರೆ ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಇದು ಹೋಗ್ತಿರ್ತದೆ, ನೆಕ್ಸ್ಟ್ ಇದಕ್ಕಿಂತ ಮುಂಚೆ ಇದು ಹೋಗ್ತಿರ್ತದೆ, ಅಂದ್ರೆ ಇದಕ್ಕಿಂತ ಇದ್ದಂತ ಏನಿದೆ ವೆಲಾಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ಹಿಯರ್ whatever the upper layer fluid or liquid having the velocity is high, The velocity is high. ಅದಕ್ಕಿಂತ ಇದು ನೆಕ್ಸ್ಟ್ ಮೂವಿಂಗ್ ಅಂದ್ರೆ ನಾವೇನಾಗುತ್ತೆ ಕಡಿಮೆ ಇರ್ತದೆ. ಮತ್ತೆ ಅದಕ್ಕಿಂತ ನೆಕ್ಸ್ಟ್ ಮೂವ್ ಮತ್ತೆ ಕಡಿಮೆ ಇರ್ತದೆ. ಮತ್ತೆ ನೆಕ್ಸ್ಟ್ ಏನಾಗುತ್ತೆ ಮತ್ತೆ ಕಡಿಮೆ ಇರ್ತದೆ. ರೈಟ್? ಸೊ ನಾ ಈ ರೀತಿ ಆಗುತ್ತೆ. ನೆಕ್ಸ್ಟ್ ಅದಕ್ಕಿಂತ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಅದಕ್ಕಿಂತ ಮಾಡಿ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಿಯರ್? ಇಷ್ಟೆಲ್ಲ ಕಡಿಮೆ ಬಂದಾಗ ಸೊ there is resist what relative motion. Relative motion ಅಂದ್ರೆ ನೋಡಿ ಇದಕ್ಕೆ relation, ಇದಕ್ಕೆ relation, ಇದಕ್ಕೆ relation. So whatever the relative motion is, that is resisting by this property of viscosity. This property of viscosity ಅದನ್ನ ನಾವೇನಂತ ಕರಿತೀವಿ viscosity ಅಂತ ಹೇಳ್ತೀವಿ. It tends resist relative motion between different layer. ಇದು ಒಂದು ಲೇಯರ್, ಇದು ಒಂದು ಲೇಯರ್, ಇದು ಒಂದು ಲೇಯರ್, ಇದು ಒಂದು ಲೇಯರ್, ಇವಿಷ್ಟು ಲೇಯರ್ ನಡುವಾಗ ಏನು ಕ್ರಿಯೇಟ್ ಮಾಡಾಕತ್ತೀವಿ ಅಂತಂದ್ರೆ ರಿಲೇಟಿವ್ ಮೋಷನ್ ಅನ್ನು ರೆಸಿಸ್ಟ್ ಮಾಡಾಕತ್ತಿ. ರಿಲೇಟಿವ್ ಮೋಷನ್ ಏನು ಮಾಡಾಕತ್ತಿ? ರೆಸಿಸ್ಟ್ ಮಾಡಾಕತ್ತಿ. ಸೊ ದಟ್ಸ್ ವೈ ಇಟ್ ಇಸ್ ಕಾಲ್ಡ್ ಆಸ್ what viscosity. It is called as what viscosity. ಅದನ್ನ viscosity ಅಂತ ಹೇಳ್ತೀವಿ. So here in this case the upper layer has right more velocity, right? So the surface or down layer, last layer has less velocity. Very important. ಗೊತ್ತಿರಬೇಕು. So ಈ ಪ್ರಾಪರ್ಟಿ ನಾವು ಏನಂತ ಕರಿತೀವಿ? ವಿಸ್ಕಾಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಏನಂತ ಕರಿತೀವಿ? ವಿಸ್ಕಾಸಿಟಿ ಅಂತ ಕರಿತೀವಿ. ಗೊತ್ತಿರಬೇಕು. Right? So here here in these layers, topmost layer has high velocity. Here downward layer has less velocity. Right? So here, whatever the difference between these two velocities, that is called velocity gradient. Velocity gradient. ಏನಂತ ಕರಿತೀವಿ ಅಂತಂದ್ರೆ velocity gradient ಅಂತ ಹೇಳ್ತೀವಿ. Velocity gradient. Right? So ಇದು ಗೊತ್ತಿರಬೇಕು. ಈ ನಮ್ಮ ಪ್ರಾಪರ್ಟಿ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? ವಿಸ್ಕಾಸಿಟಿ ಅಂತ ಹೇಳ್ತೀವಿ. ವಿಸ್ಕಾಸಿಟಿ. And here the flow is laminar flow. ಎಂತ ಫ್ಲೋ ಇರ್ತದೆ ಅಂದ್ರೆ ಇಲ್ಲಿ laminar flow ಅನ್ನು ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. laminar flow ಆಲ್ರೆಡಿ ಡಿಸ್ಕಸ್ ಮಾಡಿದ್ವಿ. ರೈಟ್? ಗೊತ್ತಿರ್ತದೆ. After this one, coefficient of viscosity. Here in this portion of liquid, AB is fixed. AB is fixed, right? Or we can write it like this also. Or AB, CD, AB, CD, right? Here in this case, what happened? AD is fixed. AD is fixed, correct? If we move, or if what the liquid flows, what happens? Like this happens. Like this happens. E, F. See, the ABCD portion, when the liquid flows, the shape of that moving portion is looking like AEFD. So write it. When it becomes AEFD, from here to here, there is a velocity. Here to here, there is a velocity. So then, what is that velocity? So that is del V is equal to delta x into distance divided by time is equal to the rate of change of displacement. E by t is equal to V is equal to d into t, right? So here what happens? V is equal to del x into t. Del x into t. Or we can take del v also. From here to here, each distance ತಗೋತೀವಿ. From here to here, ಇಷ್ಟು distance ಏನು ಮಾಡ್ತೀರಿ ತಗೋತೀವಿ. ಅಥವಾ ಏನು ಬರೀಬಹುದು? ಹೀಗೂ ಬರೀಬಹುದು. ನೋಡ್ರಿ, del x is equal to v into del t. Del x is equal to v into del t. ಈ ರೀತಿ ಬರೀಬಹುದು. Right? So, ಇಲ್ಲಿ ನೋಡಿ ಗೊತ್ತಾಗುತ್ತೆ. V is equal to del x divided by del t. The rate of change of displacement is called as velocity. The rate of change of displacement is called as velocity. Right? ಈ ರೀತಿ ನಾವು ಏನು ಮಾಡಬಹುದು ತಗೋಬಹುದು. Right? So here we got V is equal to del x divided by del t. Del x divided by del t. See, here our shearing strain is continuously going. Here our shearing strain is what? Continuously going. What happens here? Here our shearing stress or shearing strain. Here shearing strain increases continuously in this liquid, right? So what happens here? That becomes delta x divided by here. That is shearing strain, right? Shearing strain. That is delta x divided by So here strain rate is strain rate. So strain will change ಆಗಬೇಕಾದ್ರೆ ಎದ್ರ ಜೊತೆ ಟೈಮ್ ಚೇಂಜ್ ಆಗಬೇಕಾದ್ರೆ ಟೈಮ್ ಜೊತೆ ಚೇಂಜ್ ಆಗಬೇಕಾದ್ರೆ. So strain rate is equal to del x divided by L divided by del t. So then this is said strain rate is equal to what L, sorry, what is that? Delta x L into delta t. Delta x L into delta t. So here sharing stress divided by strain rate. Strain rate. See, here the ratio of sharing stress divided by strain rate is called as neta. It's called as neta. Here the neta is called as coefficient of viscosity. Coefficient of viscosity. See, here this is sharing stress. Force divided by area. Force divided by area. So see here this one. Can I write del x divided by del t? Even in once again del x divided by del t is equal to what? V. Right? So then V divided by L. V divided by L. So this is V divided by L. Right? So next, FL divided by VA. FL divided by VA. So this is our neta, coefficient of viscosity. Coefficient of viscosity. In this case, F is our tangential viscous force. F is tangential viscous force. F, tangential viscous force. Got the picture, right? So A is area of layer. Area of layer. So here SI written as Newton second per meter square. Newton second per meter square. Or Poiseuille ಅಂತ ಕರೀತಾರೆ. Poiseuille, right? Poiseuille. Poiseuille ಅಂತ ಕರೀತಾರೆ. ಗೊತ್ತಿರಬೇಕು, right? So ಇದರ dimension formula ml is 2 minus 1 t raised to minus 1. T raised to minus 1. The dimension formula. Right. So this is coefficient of viscosity. Coefficient of viscosity.